So let's look at the current picture here. I would like to ask you to find the volume of the solid generated by rotation of the shaded purple region along the axis y equals -2. And it is the first ever time we see a problem where I'm asking you to find the volume of the solid. And the axis of rotation is not the x-axis or the y-axis. But first of all, please think about what kind of solid you're getting in this picture. So I understand that my drawing is not perfect, but approximately speaking, you're getting a picture like this. And you see, in this case, it is not a full solid because you see there's an empty part, the red part that you need to cut out from the whole thing here. And in that case, to get the volume of this solid, we need to use our original formula based on the method of Washer. So basically, based on the Washer method, it means you have to do the volume of the outer solid minus the volume of the inner solid like this. And let's look at this problem. You see, although you're not rotating along the x-axis, but conceptually, the rotation is kind of in the same direction as the x-axis, right? Because our axis y equals -2 is actually parallel to the x-axis, which means conceptually they are the same. And if you look at the way how we get the volume formula by the Washer method, we have to imagine that this purple part is actually full in the solid, and in that case, the cross-sectional area you draw would be a circular disc, and one disc correspond to one line like this. So I have to make it more clear here. So basically, the outer solid is based on this outer radius. Because of what? Because if you imagine that the whole solid is full, this is exactly the outer solid we look at. And this outer solid represents the outer disk here. And if this disk is full, you'll get the full solid, right, for the purple part, which is the outer part here. So this is the outer part. Please think about it. In that case, I think it must be a dx integration because first of all, conceptually, it is quite the same as the x-axis rotation because our axis is actually parallel to the x-axis. And let's write down what is AB. The AB here correspond to the leftmost point and the rightmost point. Let's look at the picture at the top left. You see the leftmost point is 0. I put 0 in the volume formula. And the rightmost point is based on this. You see the x-axis, I mean the B here, which is the rightmost point on the x-axis. It is actually the x-coordinate of the intersection of the two lines, right? The intersection of the two lines are y equals 9 and y equals x cubed plus 1. If you set them equal, you can solve for the equation which is x cubed equals 8, which means x is actually 2 in this case. It means that this b is actually 2. So let me put it in the formula now. And that's basically the first step. And the second step is to write down exactly what is the R out and the R in here. And let's think about this problem very carefully. Please look at the outer radius. Maybe I use a black color here to make it more clear. You see, this outer radius is the radius of the circular disc, which is basically the outer disc, which will generate the outer solid, right? And now, what is this length exactly? You see, this part, which is the length below the x-axis. This is the length between the x-axis and the y equals -2, right? And this length is exactly 2. And which means in our outer radius here, it should be 2. So I'm writing it on the right-hand side, 2 plus something. 2 plus whatever length you have on here. And this length is what? This length is basically the y coordinate of this point. And this point, the y coordinate is based on this function, right? Which is exactly y equals 9. So it gives you a fact that this one is based on the outer function, which is y equals 9. So which means I'll just directly write 9 here. And similarly, can you tell me the inner radius? The inner radius is what? The inner radius is based on the red solid, which is the part that you need to cut out here from the full solid. And of course, it's based on this curve. and this curve from above it is y equals x cubed plus 1. And you see, same as the previous case when we find the outer radius, we have to add 2 to our inner radius now, because we always have to add this length. You see, if I use the black color now, basically it's the inner radius. This part is 2, because it's the length between the x-axis and the axis y equals minus 2. 2 plus whatever the vertical length of the point sitting on the curve y equals x cubed plus 1. So same as here. So the inner function is y equals x cubed plus 1. So I put the inside here. After adding 2, it should be x cubed plus 1 here. And that's basically the volume formula of this current solid. And I trust that you are able to do these volume calculations. So I stop the class here, and that's the end of this video.